As we look at chemical bonds and molecules, we gain an appreciation for the predictive power of Lewis dot structures. So let's look at a few Lewis dot structures and see what they predict about molecules. Ozone is O3, 3 oxygen atoms bonded together. Here's a Lewis dot structure that follows all the rules. The octets are filled, the correct number of electrons are used, the molecule fits together. So here I have ozone, but with ozone, as for a lot of molecules, you can actually draw another equivalent Lewis dot structure. Here they're very similar. The double bond is just on this oxygen as opposed to this oxygen. So what does that tell us about the molecule? Well, the Lewis dot structures themselves would predict, well, for these bonds, one's a double bond, one's a single bond, there'd be a difference between the two bonds. That is, the double bond might be shorter, stronger than the single bond, and ozone would be a cockeyed molecule. It turns out spectroscopically we can show that the bonds in ozone are identical. These two bond lengths are the same. So the true molecule is more an average of these two Lewis dot structures. The bond isn't a double bond or a single bond, it's somewhere in the middle, a bond and a half. So ozone with its two equivalent bonds has what we call a bond order of 1.5. And we'll define the bond order. We'll take the number of bonds predicted by the Lewis dot structure divided by the number of physical bonds I have to make. So in this case, there's 3 bonds predicted by the Lewis dot structure and 2 physical bonds I have to make. 3 over 2 is 1.5. Our 1.5 bond strength that looks like what it should be based on these two. An average of these two, a double and a single, 1.5. Let's look at another example. Here's carbonate. Carbonate CO3 minus 2. And again, I'm going to draw a Lewis dot structure. This time I'm going to leave off the electrons around the oxygen just for clarity. But there's 3 places I can put that double bond. So 3 physical bonds that I need to make. There's 4 bonds predicted by the Lewis dot structure. So 4/3 or 1 1/3 bond order for carbonate. Again, in carbonate, the true answer is an average of these 3, and each CO bond in carbonate is the same. Same thing in benzene. Benzene is a molecule where you can draw the double bonds in one position or another position, but you can do the bond order calculation and find out, again, this one looks like it's going to be 1.5. Equal numbers of double and single bonds. And indeed, benzene, the bond order is 1.5. So Lewis structures will help us predict the bond order, relative bond strength in molecules. Now we can use Lewis dot structures to predict a myriad of other features like the geometry of the molecules, and that's what we'll look at next.